Alrighty, let's see. That's time is of the essence here. Pacific Atlantic water flow, medium. There is an M by N rectangular island that borders both the Pacific Ocean and Atlantic Ocean. The Pacific Ocean touches the island's left and top edges. The Atlantic Ocean touches the island's right and bottom edges. Okay. The island is partitioned into a grid of square cells. You're given M by N integer matrix heights, where heights of RC represents the height above sea level of the cell at coordinate RC. Okay, so like an elevation map. The island receives a lot of rain, and the rainwater can flow to neighboring cells directly north, south, east, and west if the neighboring cell's height is less than or equal to the current cell's height. Oh my god, it's another tank problem. Water can flow from any cell to any cell adjacent to an ocean into the ocean. So water can flow in flat elevations. Return a 2D list of grid coordinates result. The result of at I equals Ri. R sub I, C sub I denotes that rainwater can flow from that cell to both Atlantic and Pacific Oceans. Okay, so here 7 can flow to 4, can flow to 2, can flow to Pacific, or 7 can flow to 1. So all these are highlighted cells that can flow to both oceans. 2 doesn't have a way to flow to Atlantic. This thing. Interesting. Okay. So this can be in any order, or was it? Notes the rain can flow maybe in any order. Return a 2D list of grid coordinates the result of I equals R plus 11. So 0, 4, 1, 3, 1, 4, 2, 2. What if, yeah, I assume the output can be done in any order. Okay. Note that there are other possible paths for these cells to flow. Yeah. Height 1. So output 0, 0. So 200. 200 by 200 square island is the biggest it can be. Okay. Okay. Think about this. So medium. This seems okay-ish. So I think anything that is on the left or anything on the sides should be able to flow into that ocean. Right. Actually, anything on the top right and bottom left corners should, by definition, be able to flow into both. So those are always going to be part of the answer. And then the other question is like, so if I think about the Pacific Ocean, anything on the top side and on the right side, or left side, should be flowable into the Pacific. And then I can extend that to any cell that's adjacent to, it's kind of like a fill or a flood maybe. You can color the Pacific, or you can assume the Pacific can hit any cell that is a Pacific and also is to the is adjacent to Pacific that is equal or higher in height. So I colored this as Pacific, I colored this as Pacific. This can be Pacific because it's equal to this. This can be Pacific, this can be Pacific. And then this can be Pacific. Okay, so maybe I have something where it's a yeah, maybe I just have something where I color in things that are Pacific. Have a separate matrix that colors in the things that are Atlantic, and then iterate over them to see what is the overlap, and the overlap is going to be the ones that flow into both. Okay. So I'll say pack color or pack matrix. Actually, let's go and just define the rows and columns. Rows, columns is the length of the heights and the length of heights of 0, which is how many rows and columns there are. And then let's go ahead and create a Pacific matrix, which is going to be, I guess, false times the number of columns for every k in rows. And then have another matrix for Atlantic. Matrix is false times columns for k in range rows as well. And these matrix will be true if matrix where water can flow to respective ocean. And so I need to initially assign it to be true. I need to initially assign it to be true for the first row and first column. So for C in range calls Pacific matrix at row 0, that column is equal to true. And I think I need to create a stack. I think it'll be either a stack or a queue or a deck. Because I want to process it. I think a stack is probably fine. So it's just like a coloring stack. And stack.append this row and this column. Row 0, this column. And then for every row in range 1 to the number of rows, so I skip over this first element and go over this first column. Pack matrix at that row column 0 is equal to true, stack append 0 or that row column 0, and then while stack guess I go every neighboring cell from this spot. So let's go include helper method, define is valid for RC, return 0 less than R less than rows, and 0 less than equal to C less than columns. RC equals stack dot pop and a delta list 1 1. This is all the different ways of movement from a cell. 1 negative 1 negative 1 1 negative 1 negative 1 for every dr dc in my deltas. nr nc equals r plus dr c plus dc if is valid nr nc and we have the current height. Current h is heights at this row column, and current height is less than or equal to, actually I need to check if this is not already colored, and pack matrix at nr nc is false, so this is not already previously understood to flow to the Pacific, and height is less than or equal to heights at nr nc. Maybe I'm going to shorten this thing. Matrix. What is the short abbreviation for matrix? Is it just mat? Generally uses mat. Pacific matrix. Ugh, God. Not short enough. So if it's a valid cell and it's currently not true, and this height is less than or equal to that height, then therefore packing matrix at nr and c is equal to true, and stack dot append nr and c. I think that's it. And then let's go ahead and just print out the, let's say for every row in pack matrix, print that row, turn 0, I guess. Let's see if this works. Pack matrix, oops. So this should be, what is delta? Okay, so So it's true, 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 true. Okay, that's fine. Okay, so that, wait, that shouldn't be true right here. Oh boy. How did that become true? Is valid. I should never have gotten to that point. Oh boy. So it is 4031. So this is row 012334. How did it get there? Guess I could have gotten there from an adjacent cell. It should have stopped. So it got here. So water flows here. Current height is 5. Okay, I'm gonna go ahead and just verify that the initial thing is correct. Should be just the first row and first column is thing true. Okay. Alright, let's just really dive into here. Okay, so 4 zeros to cell. We shouldn't add anything. Then set 3 1. How did it get here? So that's not adjacent to 4 0. I'm so stupid. These are diagonal directions. Oh my god. Orthogonal directions. 1 0 0 1 negative 1. Yeah, that's so stupid. Negative 1 0 and 0 negative 1. So left, right, down. Okay, that should be better. I think I need to move this thing to be after the loop. I guess that's fine. Let's go infinite, really? Okay, true, true, 3 trues, 2 trues, 1 true. Okay. So that seems to work for the Pacific matrix. And now for the Atlantic matrix. So I think maybe I can actually do it here as well. Atlantic matrix would be Atlantic matrix for the bottom row. So negative 1 is the row, column C. It's true. A separate stack here. I'll say this is Pacific stack, P stack. restack, restack, and then the Atlantic stack append can I actually use -1? Or do I have to use rows minus? Yeah, I think I have to use rows. That's rows minus 1 minus. I guess it's just rows minus 1. Column. Atlantic stack. And then this is going to be a little tricky. So Atlantic stack is the right side. Right side, but this has to go upwards this way. So if this is range 1 to rows, I think I should probably just do something. So this is Atlantic. Oh, this would be ATL. Atlantic matrix at column is -1, row is R minus 1. A stack and R minus 1, 0. No, R should be variable. Column should be cols minus 1. And this is wrong. No, this is constant, right? Rows is constant. Okay, yeah. Okay, that's right. And then while A stack RC equals A stack dot pop. Current height is height set RC or DRDC and delta NRMC for NRMC equals R plus DR, C plus DC, if is valid NRMC and not Atlantic matrix at NRMC, and the current height is less than or equal to the heights at NRMC. Atlantic matrix at NRMC is true. A stack append NRMC, and then I have an answer list for every row and range rows, for every column and range cols. If its specific matrix flows to RC and Atlantic matrix flows to RC, then answer append R comma C as a list, return the answer. Okay. Okay, let's see if this works for the general case. Okay, simple enough. I wonder, I mean, I guess I could do a three-dimensional, make this into like 2 layers, dimension 1, dimension 2, and have one single matrix. Probably unnecessarily complicated there, maybe. I'm fine decomposing that variable into, or not having a 3D matrix variable. It's fine. This is a little verbose. I don't know if there's a better way of doing this. Not terrible. It's kind of wordy. Maybe delta. Do need to have different stacks for the different flows. Okay. Yeah, I guess this is fine. Set top and bottom cells to be flowable to Pacific and Atlantic oceans, respectively. And so we set left and right cells, top and bottommost cells. Flowable to Pacific and Atlantic oceans. And then this is find flowable cells from current stack of Pacific cells. And this is find flowable cells from current stack of Atlantic cells. And then this is answer is the list of overlapping cells flowable to both Pacific and Atlantic. Okay, summary. So create or have two matrices size equal in dimensions to island that identify which cells can flow to Pacific and Atlantic oceans. Start, for example, with Pacific. Every starting cell on the top and left sides are flowable. Evaluating each of those cells if there are any neighboring cell with height equal or higher. That cell can also flow. So use flow to Pacific. So for instance, if you have a 3 starting cell on the left side that flows to Pacific 3, then if there was like a 20 here, then the 20 would also flow through the 3. But if it's the smaller height, then obviously can't. Have a stack of tuples row column of those initial flowable cells. Check when processing the stack, check every neighbor of the current cell to see if it's flowable and add to stack. If so, also set state to true in matrix. Do similarly for the Atlantic stack. Finally, the overlapping the cells that are true in both matrix, i.e. can flow to both Pacific and Atlantic, are the answer cells. So just knowing kind of the syntax about how you quickly set the stack, just a list basically. When you process stack, you just pop from the end of the list, and then the quick way to iterate over the neighbors is one, defining a list of deltas, the change in the row and column, just a set of tuples. In this case, changing the row, this is changing the right one, nothing vertically. This is changing the row actually. Down one, nothing horizontally. That's changing column, right one, up one, left one. And then you just have iterating through the deltas, finding what the new value of the row and column is, checking that row and column is inbound using a helper function, and then checking that it's not already defined to be flowable to that, and then also finally checking that the heights are correct. If that's all true, then you found a new place that it flows from. So set that to be true in the matrix and append that place to be analyzed from the stack. Time complexity is to be O of n, or O of mn, where n, where island size is m by n. Basically, the stack should process each cell kind of at most kind of constant amount of time. It shouldn't really do much duplication. Can only add to the stack if initially false. So once it sets it to true, then it doesn't add to the stack. And the final creation and final answer list determination is also O of mn. Iterate through all the range of iterate over the rows and columns there. And then space complexity should be O of mn for the Pacific and Atlantic flowable matrices. Just the calculation of which ones there are, and also I guess the tuples and also the stack can have at most n by n tuples in it. So